Three brave explorers are going to the Amazon jungle to explore. They're hoping to make new discoveries and they plan on documenting everything they find. However, during their flight to the jungle, things started to go wrong.
I'm gonna use the bathroom real quick.
Alright.
Oh no, we're gonna crash!
Brace for impact, guys.
What's happening? What? Wait, what?
Is everyone okay?
They're over here.
Josh, get up.
I'm okay. Why am I so wet? Oh, this is my urine? Oh, jeez.
Alright, we need to fix our plane. Let's start walking and looking for stuff.
I see a temple.
I wonder what riches are inside there. Let's go!
Welcome to my temple.
Who are you?
I am Guru Seen, but all my friends call me Guru Daddy because I am the father of all nature.
Ooh, hi, Guru Daddy.
We're not your friends.
Oh, we met a new friend. I want to join in.
So what brings you to my humble abode?
Well, we were flying to the Amazon jungle to explore, but our airplane crashed.
Oh, well, how very unfortunate. Did you plane malfunction?
No, it wasn't a plane malfunction. It was some freak weather accident that happened.
Oh, well, lucky for you, I happen to be an expert at weather. If you listen to my tales and identify what the weather accident was, I can perhaps help you. I will fix it.
I, for one, think that we crashed because of an earthquake.
I remember back in my day, when the earthquakes happened, we had an explanation for it. Well, you see, back in my day, we used to think that earthquakes happened when League of Legends players used to play the grand tournament. And in their tournament, they used to get mad and stomp their feet and fists, and this would cause vibrations to go throughout the floor. And these vibrations would accumulate and cause an earthquake, causing the earth to rupture and crumble.
Oh my god, you messed up so bad. Why'd you do that? You messed up. Come on. You played Mario. This was championship. Why are you playing Mario in League of Legends? This was a championship.
I thought this was a Mario championship.
What? League of Legends. There is no Mario championship.
I don't think that's how earthquakes are formed, and they don't affect things in the air either.
Josh is right. An earthquake definitely couldn't have crashed our plane. Plus, that's not even how earthquakes are caused.
We all know how earthquakes are formed when platonic structures of the Earth's crust are ruptured. However, today we will be focusing on how they are measured. They're measured by something called the Richter scale, which is a logarithmic scale. As you can see on the whiteboard, the function of the Richter scale is shown as log of A over A naught, in which A is the magnitude of the amplitude of the wave of the earthquake that is detected, versus A naught, which is the smallest detectable amplitude by the seismograph that is measuring the earthquake. For example, if you measure a amplitude that is 400 times the smallest detectable wave of by a seismograph, then you can say that the log of 400 is equal to 2.6. Thus, the R value, or the Richter scale value of the earthquake, will be 2.6. It is important to note that a logarithmic scale is very unlike a numerical scale, in which in a numerical scale the difference between 3 to 1 and 5 to 4 are the same, whereas in a logarithmic scale they're different. The value inside of a log with an R value of 3 is 1,000, and R value of 2 is 100, and R value of 5 is 100,000, and R value of 4 is 10,000. Knowing that, if we look at the difference between an R value of 3 and an R value of 2, the value inside the log function is 900, and the difference between the value inside the function of a log with the R value of 5 and 4, on the other hand, are 90,000. Now this is a quite stark difference, even when both are differences of 1. Now if you look at it in the entire scale, you keep on seeing that between each consecutive integer in the logarithmic scale for the Richter scale, the difference between each integer increases by a consistent amount. For example, between 0 and 1, the difference is 9. Between 1 and 2, the difference is 90. And between 2 and 3, the difference is 990. This continues to grow until the difference between R value of 8 and 9 is totally different from the different R value of 3 and 2.
Wow, I never knew you guys were such intelligent human beings.
Thanks, Bear Daddy.
Well, if an earthquake wasn't the cause of the accident, then what was?
I, for one, believe it was a tornado that sucked our plane out of the air and into the ground.
It's always the tornadoes. They just love to suck, don't they? Anyways, them tornadoes, we all know how they are formed.
Wow, that's so cool. I wish I had one of those.
It's a world record. Oh, gotta go
Whoosh,
faster,
wow,
man.
your
Whoosh.
skins are spinning so
Whoosh.
fast.
Oh, whoosh. Not going fast enough.
That's dumb. There's no way tornadoes are formed like that.
It's not?
No, not at all. Tornadoes are formed when hot wind mixes with cold wind.
Yes, and more specifically, it happens when hot, moist air near the ground gets pushed up by a gust of cold wind. As the hot air rises, it mixes and starts to turn to the cold wind.
Well, is that how tornadoes start to spin and get super big? But wait, even if it was a tornado, why didn't we get a weather forecast?
That's a good question. It's very unlikely that a tornado caused our plane to crash because the winds are noticeable from a very far distance.
What we do know about tornadoes is that they're definitely not caused by fidget spinners. And what we additionally know is that meteorologists have studied tornadoes to the extent that we somewhat know and are able to predict patterns of tornadoes. First of all, tornadoes are caused when you have hot, moist air near the ground. And this hot, moist air is encountered with a steady gust of cold, dry wind. Note that this cold, dry wind has to be fast and consistent and persist throughout the time the tornado has been created in order for the tornado to increase in size. So now as this cold gust wind interacts with the warm air rises. Warm air always rises, and this is a known fact in meteorology. And as it rises, this creates a current flow that's circular. As the warm air rises, the cold air flows down. This causes a circular pattern which will be effective in creating a tornado later on. This can be demonstrated when you see the circular current spin in a three-dimensional plane. Meteorologists are able to do this by using certain computer models, but ultimately what they fact is that the consistent rising up of the warm air results in the tornado, which is originally horizontal. The current that's originally horizontal would become vertical and thus result in the tornado. Now, it is very important to know that meteorologists, when they're observing these tornadoes, actually use several different variables to measure and predict the direction of tornadoes. Some of these measurements are turbulence, velocity of the wind, velocity of the rotation of the wind, and the angular rotation, and time. These are all important factors in determining the direction and magnitude of a tornado. One important variable to delve deeper into is turbulence, since this is a quite interesting variable that meteorologists measure when observing tornadoes. Since turbulence is dependent on three other variables that meteorologists use when graphing probability plots for tornadoes, there's three integrals. These three integrals are necessary for the equation, and as you can see on the whiteboard, the equation has two main variables, which is the uppercase v, which is volume, and lowercase v, which is velocity. Note that the rotational, the ROT, behind the second v is specifically to point out that that v is for rotational velocity of the winds that are spinning around the tornado.
Whoa, I did not know that. Wait, but if it's not a tornado, then what is it exactly?
I think lightning struck our plane and caused us to crash.
It had to be lightning. I remember there were dark clouds and flashes all around us.
Oh yeah, I remember.
Be quiet, Leo. You were in the bathroom. So, Guru Sid, do you think you could fix our plane and help us start our journey again?
Of course I will, especially with my D Zappa Native 3000, 1638, 1738, 3400, 420. I will be able to do that very easily. Okay, and time to use my D Zappatron.
And just like that, our three brave explorers were back in the air on their way to the Amazon jungle. Their mathematical knowledge about natural disasters impressed the guru, who in turn graciously fixed their plane.